guys probably get the idea of what's going on in this lab by now, but just to really seal it in there, we're going to click on Gay-Lussac's law, and you can see what happens now. We're dealing with pressure and temperature, and volume is being held constant. So we're not changing volume. We're going to change pressure and temperature. Hamilton's or Gay-Lussac's law is P over T equals P over T. That's how they're related. So P over T equals P over T. P1 over T1 equals P2 over T2. And they say change the temperature to 158. So I'm going to change the temperature. So notice how they're moving. I'm going to change the temperature to 158. Whoa. They're really moving slow now. All right, so that's my new temperature. Now I'm going to measure the pressure. I'm going to calculate the pressure there. So I'm actually down here, I think, on 20B. So I skipped those initial questions because they're very similar to what we were doing before. I think you're able to handle them now. So I have P over T is P over T. So I've got my pressure of 1. That's my P1. My T1 is 298, and my P2 is what I'm calculating, and T2 is the 158. So this looks kind of similar to Charles' law, right, where we had this over this equals this over this, and they were directly proportional. So I would expect that as I decrease the you can actually see it happening over here. If I decrease the temperature, I'm going to decrease the pressure as well. Or if I increase one, I should increase the other. They should be directly proportional. So I'm going to multiply both sides by the 158. Multiply by 158, and that should calculate my pressure, which I could also read right there on the pressure meter. So I got a P2 of 0.53. P2 equals 0.53. Now in this case, all right, so I'm going to reset, and now they give me 4 more. When you go to the procedure, it tells you which ones you have to do. We're going to go with like 1 and 1.5, 2, change the pressure, 1, 1.5, 2, 2.5, 2.5, whatever we have there, and then you're going to measure the temperature. See how does that affect the temperature. All right, so the ones I did slightly different ones again because I don't want to give you all the answers, still making you do this, but this is what I got when I worked through it, right? So I said I increased the pressure. So the first pressure was 1, then I increased the pressure to 1.3, and then I calculated that temperature. Then I add data, don't forget to add the data. Then I went up to 2.1. You can kind of see what's happening here. They're increasing as I go, calculate, and the temperature is increasing. So if I increase the pressure, I increase the temperature, look at the molecules are going crazy now. So you're going to keep doing that for all of your points. And just like we did last time, copy that data table. So I highlight it, then copy it. We go to Excel, I opened a new sheet, I pasted that in here, done. I'm going to plot this, insert XY scatter graph, I've got that. Now this time I want temperature over here and pressure down here because I changed the pressure and then I measured the temperature that way. This is what I set, and then I'm measuring how temperature depends on the pressure. This guy. Gay-Lussac's or Hamilton's law. Alright, Guy's law. And I'm just kind of rushing here. I want to add my axes, just like I always do. That one is temperature. And then this one is pressure. And you can see they are directly proportional. Again, if I increase one, I'm going to increase the other. Left click to highlight, right click for this guy to come up, add the trend line, scroll down, display equation on the chart, and then there you go. Then don't forget to copy and paste all your graphs into the lab.